Oh, hey there, folks. This is Dr. Franklin, and this is a presentation dealing with the key aspects of the Introduction and Methodology section. In this presentation, I'll briefly review key components of the introduction. I'll also discuss key components of the methodology section. I will review different types of validity next, and then finally, to wrap up the presentation, I'll provide you some questions you should consider when evaluating the instrumentation section of research reports and when you're drafting your own instrumentation section as it relates to your individual research projects. The introduction provides the rationale for your research and prepares the reader for the methods you have chosen. Thus, you should give a concise history and background of your topic, leading into your hypotheses or questions. That is, you are using an evidence-based argument to explain the objective or purpose of your research study and what you predicted. Stating something on the order of X reported an effective study time, but this experiment was criticized by Y for methodological flaws would not be good evidence-based writing. The reason is that it fails to adequately describe the effect reported by researcher X and does not identify the methodological flaws identified by researcher Y. It wouldn't be acceptable to present merely a string of loosely related summaries of articles either, because you need to show that you understand what you are citing and how it supports a particular position. Your literature review should also show the development of your hypotheses or any of your exploratory questions and the reasons the research topics seemed worth studying. Strong introductions are those that state the research problem or the hypotheses in such a way that the method section appears to be a natural consequence of that statement. If you can get the readers to think when they later see your method section, yes, of course, that's what this researcher had to do to answer this question, then you will have succeeded in writing a strong introduction. Here are some questions to ask yourself as you plan the introduction. What was the purpose of my study? What terms need to be defined? How does my study build on or derive from other studies? What were my hypotheses, predictions, or expectations? All right, folks, so let's segue into talking about the methodology section. This methodology section details the methods and the procedures used in your research study. The research participants should be described, for example, their age and their sex. The number of people participating and the way they were selected or recruited also should be specified. Psychologists are trained to ask questions about the generalizability of results. As I review your work, I'll be thinking about the generalizability of your findings across both persons and settings is referred to as the external validity of the study. If your subjects were college students, think about how your results can be generalized beyond this specialized population and be sure to discuss these ideas later in your report. Also included in this section should be a description of any test or measures and the context in which they were used. Even if you use well-known standardized tests, still a good idea to describe them in a few sentences. By describing them, you tell me that you understand the nature and purpose of the measuring instruments you used. For instance, suppose you use the self-monitoring scale developed by psychologist Mark Schneider. In your literature search, you found that the research has shown this instrument to be three-dimensional. In your report, you might say something like this. The study participants were administered Schneider's 25-item self-monitoring scale. The original purpose of this instrument was to measure self-control and self-observation, but Briggs, Cheek, and Buss found that the scale actually measures three distinct factors described by them as extroversion, other directedness, and acting. Extroversion refers to the tendency to be the center of attention in groups. Other directedness refers to a person's willingness to change his or her behavior to suit others, and acting refers to liking and being good at speaking and entertaining. However, suppose you need to report only the nature of a particular measure and not any follow-up inferences by other researchers. For example, assume you use the need for cognition scale created by social psychologist John T. Cacioppo, and Richard E. Petty. You can succinctly describe the measure in a single sentence like this. The participants were administered Cacioppo and Petty's Need for Cognition Scale, which is an 18-item measure of the tendency to engage in and enjoy thinking. If you know something about the reliability and validity of the instrument, mention this information as well, along with an appropriate citation, but be specific. It would be vague to only say that the reliability was R equals 0.50 without also indicating whether you mean the test-retest reliability, which is the stability of the instrument from one measurement session to another, the alternate form reliability, that is the degree of equivalence of different versions of the instrument, or the internal consistency reliability, the degree of relatedness of individual items or components of the instrument when those items or components are used to give a single score. The same rule applies to the reporting of validity findings, and you see these showcased in the presentation now. Now, immediately after describing the sample or population, researchers typically describe their instruments. An instrument is a technical term for any tool or method for measuring a trait or characteristic. The description of instruments in research reports is usually identified with the subheading Instrumentation or Measures. Often, researchers use published instruments. About equally as often, researchers use instruments that they devise specifically for their particular research purposes. As a general rule, researchers should provide more information about such newly developed instruments than on previously published ones that have been described in detail in other publications, such as test manuals and other research reports. While a consumer of research would need to take several sequential courses in measurement to become an expert, he or she will be able to make preliminary evaluations of researchers' measurement procedures by applying the evaluation questions I will discuss now. Have the actual items in questions, or at least a sample of them, been provided? Providing sample items in questions is highly desirable because they help to operationalize what was measured. Note that researchers operationalize when they specify the physical properties of the concepts on which they are reporting. It should be noted that many achievement tests have items that vary in difficulty. When this is the case, including sample items that show the range of difficulty is desirable. If you are using a survey that has a great deal of open-ended questions, it would be to your benefit to provide some examples of those open-ended questions in your description. Keep in mind that many instruments are copyrighted, and their copyright holders might insist on keeping the actual items secure from public exposure. Obviously, a researcher should not be faulted for failing to provide samples when this is the case. Question number 2 deals with, are there any specialized response formats, settings, and/or restrictions described in detail? It is desirable for researchers to indicate the response format. For example, multiple choice, responses on a scale from strongly agree to strongly disagree, and so on. Examples of settings that should be mentioned are the place where the measures were used, for example, participants' homes, and whether one individual was present, such as whether parents were present while their children were interviewed. Examples of restrictions that should be mentioned are time limits and tools that participants are permitted or are not permitted to use, such as not allowing the use of calculators while taking a mathematics test. Qualitative researchers also should provide details on these matters. Number 3. When appropriate, are multiple methods used to collect data/information on each variable? It's safe to assume that all methods of observation, for example testing, interviewing, making observations, are flawed. Thus, the results of a study can be more definitive if more than one method for collecting data is used for each variable. In quantitative research, researchers emphasize developing objective measures that meet statistical standards for reliability and validity, which are discussed later on by me. When Researchers use these highly developed measures. They often do not believe that it is important to use multiple measures. For example, they might use a well-established multiple choice reading comprehension test that was extensively investigated as to its validity and reliability prior to the publication of the test. A quantitative researcher would be unlikely to supplement such highly developed measures with other measures such as teachers' ratings of students' reading comprehension or some other measurement technique such as having each child read aloud and discuss what they learned from reading. Thus, it is not traditional to use multiple measures of each variable in quantitative research. In qualitative research, researchers are more likely to use multiple measures of a single phenomenon for several reasons. First, qualitative researchers strive to conduct a research study that is intensive and yields highly detailed results, often in the form of themes supported by verbal descriptions as opposed to numbers. The use of multiple measures helps qualitative researchers probe more intensely from different points of view. In addition, qualitative researchers tend to view their research as exploratory. In advance of conducting exploratory research, it is difficult to know which type of measure for a particular variable is likely to be the most useful. Finally, qualitative researchers see the use of multiple measures as a way to check the validity of their results. In other words, if different measures of the same phenomenon yield highly consistent results, the validity of the instrumentation, including the interpretation of the data, might be more highly regarded as being valid than if only one data source was used. Sometimes it is not realistic to expect researchers to use multiple measures for all variables. For instance, measurement of some variables is so straightforward that it would be poor use of a researcher's time to measure them in several ways. For example, most researchers would be very confident in the validity of asking second grade students to perform the one-digit multiplication facts on a paper and pencil test. It would be needlessly redundant to ask the students to demonstrate their achievement a second time by having an interviewer ask the same students to answer the same multiplication facts. Number 4. For published instruments, have sources where additional information can be obtained been cited? Some instruments are published only in the sense that they were previously reproduced in full in journal articles. Such articles typically describe the development and statistical properties of the instruments. Other instruments are published by commercial publishers as separate publications, for example, test booklets that usually have accompanying manuals that describe technical information on the instruments. Number 5. When delving into sensitive matters, is there a reason to believe that accurate data were obtained? Some issues are sensitive because they deal with illegal matters such as illicit substance use, gang violence, and so on. Others are sensitive because of societal taboos such as those regarding certain flaws of sexual behavior. Still, others may be sensitive because of idiosyncratic personal views on privacy. For instance, age and income are sensitive issues for many individuals. Participants often decline to answer these questions or may not answer honestly. Thus, self-reports by participants may sometimes lack validity. A common technique for encouraging honest answers to sensitive questions is to collect the responses anonymously. For instance, participants may be asked to mail in questionnaires with the assurance that they are not coded in any way that would reveal their identity. In group settings, participants who respond in writing may also be assured that their responses are anonymous. However, if a group is small, such as a class of 20 students, some participants might be hesitant to be perfectly honest regarding highly sensitive matters because a small group does not provide much cover for hiding the identity of a participant who engages in illegal or taboo behaviors. With techniques such as interviewing or direct physical observation, it is usually not possible to provide anonymity. The most a researcher might be able to do is assure confidentiality. Such an assurance is likely to work best if the participants already know and trust the interviewer, such as a school counselor, or if the researcher has spent enough time with the participants to develop rapport and trust. The latter is more likely to occur in qualitative research than quantitative research because qualitative researchers often spend substantial amounts of time in an effort to bond and interact with their participants. If an instrument is designed to measure a single unitary trait, does it have internal consistency? A test of computational skills in mathematics at the primary grade levels measures a relatively homogeneous trait. However, a mathematics battery that measures verbal problem solving and mathematical reasoning, in addition to computational skills, measures a more heterogeneous trait. Likewise, a self-report measure of depression measures a much more homogeneous trait than does a measure of overall mental health. For instruments designed to measure homogeneous traits, it is important to ask whether they are internally consistent. That is, to what extent do the items within the instrument yield results that are consistent with each other? While it's beyond the scope of this lecture to explain how and why it works, a statistic known as Cronbach's alpha provides a statistical measure of internal consistency. As a special type of correlation coefficient, it ranges from 0.00 to 1, with values of about 0.70 or above indicating adequate internal consistency, and values above 0.90 indicating excellence on this characteristic. Values below 0.70 suggest that more than one trait is being measured by the instrument, which is undesirable when a researcher wants to measure only one homogeneous trait. Internal consistency usually is regarded as an issue only when an instrument is designed to measure a single homogeneous trait and when the instrument yields scores as opposed to instruments such as interviews when used to identify patterns that are described in words. If an instrument does not meet these two criteria, not applicable is an appropriate answer to this evaluation question. Number 7, when appropriate, is there evidence of some type of validity? I'll talk about two particular types of validity here. I'll talk about content validity as well as empirical validity. An important issue in the evaluation of achievement tests is the extent to which the contents of the test, that is, the stimulus materials and skills, are suitable in light of the research purpose. For instance, if a researcher has used an achievement test to study the extent to which the second graders in a school district have achieved the skills expected of them at this grade level, a consumer of the research will want to know whether the contents of the test are aligned with or match the contents of the second grade curriculum. While content validity is most closely associated with measurement of achievement, it also is sometimes used as a construct for evaluating other types of measures. The other type of validity I want to discuss is empirical validity. Empirical validity refers to validity established by collecting data using an instrument in order to determine the extent to which the data makes sense. For instance, a depression scale might be empirically validated by administering it to an institutionalized, clinically depressed group of adult patients, as well as to a random sample of adult patients visiting family physicians for annual checkups. A researcher would expect that the scores of the two groups will differ substantially in a predicted direction. That is, the institutionalized sample should have higher depression scores. If not, the validity of the scale would be quite questionable. Sometimes the empirical validity of a test is expressed with the correlation coefficient. For example, a test maker might correlate scores on the College Board's SATs with freshman grades in college. A correlation of 0.40 or more might be interpreted as indicating the test has validity as a modest predictor of college grades. Empirical validity comes in many forms, and a full exploration of it is beyond the scope of this lecture. However, some key terms that suggest empirical validity has been explored include predictive validity, concurrent validity, criterion-related validity, convergent validity, discriminative validity, construct validity, and factor analysis. When researchers describe empirical validity, they usually briefly summarize the information, and these summaries are typically fairly comprehensible to individuals with limited training in tests and measurements. Finally, does the researcher discuss obvious limitations of their instrumentation? By discussing limitations of their instruments, researchers help consumers of research understand the extent to which the data presented in the results can be trusted. If in your judgment there are no obvious limitations to the instrumentation described in a research report, A rating of NA or not applicable should be made for this particular evaluation question.